Hey everyone, and welcome to This Explainer. If you're a beginner computer science student just stepping into the exciting world of visual programming, you are in exactly the right place. Today, we're talking about building your very first Java GUI, that's graphical user interface, and taking that leap from raw lines of text to a beautiful, interactive visual canvas. I actually like to think of this whole process as managing a digital construction site. Over the next few minutes, we're going to pour the foundation, frame the walls, and eventually figure out how to move the furniture in. It's an absolutely incredibly rewarding process, and I am so thrilled to guide you through it.
Okay, let's dive into this. Here is our exact blueprint for today's build. 1. Welcome to visual programming. 2. The foundation, which is the Java frame. 3. Configuring your empty window. 4. Displaying the window. And finally, 5. Adding custom components. So, let's start building.
Starting off with Section 1, Welcome to Visual Programming, Trading the Command Line for a Canvas.
Now, making the jump from text-based coding in a black and white console to generating actual visual windows, well, it can feel incredibly intimidating. You're suddenly dealing with graphical things you can click, drag, and resize, but I want to reassure you right now, the core logic hasn't changed at all. It's just a straightforward, step-by-step process. By definition, a graphical application is simply a program that displays its contents, like drawings, shapes, and other graphical objects, inside a window, which we call a frame. Think of this definition as the master digital blueprint for the visual interface we are about to construct. It isn't magic, guys. It's literally just a new type of object we're commanding Java to generate on our screen.
Let's transition over to Section 2, the foundation, Java JFrame laying the groundwork. If you're going to build a physical house, you absolutely need an empty plot of land to build it on, right? Well, in Java, before you can draw colorful shapes or add interactive buttons or type in text fields, you need a core tool to hold all of that stuff together. That plot of land is the JFrame. A JFrame is defined as a top-level container of GUI components that serves as the application's main window. That phrase right there, top-level container, is the secret to the whole system. It basically means this is the fundamental box that must hold all the graphical components your user will eventually see. Everything you want to show the world has to be securely contained within this mainframe. But before we can actually use this fantastic foundational tool, we have to tell Java where to find it. Java comes with a massive, incredibly powerful tool belt, but the JFrame isn't strapped to the default one you get when you just start typing. You have to bring it in from Java's Swing library. You do this right at the very top of your code file with a simple statement, import jxas.swing.jframe, . Boom. This immediately makes the class available for you to use. And this brilliantly illustrates the next step. Pouring that foundation only takes a single line of code. JFrame appFrame equals new JFrame. By doing this, you are successfully constructing the JFrame object. You're basically telling the computer's memory, hey, carve out a plot of land for my main window right now. And just like that, your empty foundation exists in the computer's system, totally ready to be built upon. Moving right along to Section 3, configuring your empty window, framing, and paint. Now, a raw foundation simply isn't enough to live in. It's literally just flat concrete in the ground. Before anyone can actually use our digital house, we need to frame the walls, maybe add some paint, and essentially configure its exact dimensions and identity. To make our frame perfectly usable, we have a simple 3-step checklist to follow. Step 1, set size. Step 2, set title. Step 3, set close operation. Think of these 3 steps as framing the walls, putting up the street address, and installing the front exit door of our digital house. Let's look at exactly how we execute each of these steps in our code. First up, the walls. We call the set size method on our newly created app frame. This method takes 2 arguments, width and height, both measured in pixels. So appFrame.setSize 400, 250 makes our window 400 pixels wide and 250 pixels tall. I gotta warn you right now though, a lot of beginners forget this exact step. And if you forget to set the size, your frame will be successfully constructed, sure, but it'll be so incredibly tiny that you literally won't even be able to see it on your monitor. Next up, we give the house an address, or in this specific case, a readable name at the top of the window. We use appFrame.setTitle, passing in a string like an empty frame. Whatever string you pass in here will be proudly displayed right at the top bar of your graphical application. Quick pro tip for you here. You don't actually have to do this on a separate line. You can optionally pass this exact string directly into the initial JFrame constructor when you first create the object. Either way works perfectly. It's totally up to you. And finally, step 3, the all-important exit doors. At frame.setDefaultClose passing in jframe.exitOnClose. This is absolutely crucial. Have you ever clicked the red X on a software window and it just stubbornly won't close? Yeah, that is exactly what happens if you forget this line of code. This configuration ensures that when the user clicks that little X button in the corner, the entire application actually stops running in the system background.
Which brings us to section 4, displaying the window, turning on the lights.
Now, what's really interesting about this is the fact that at this point, you've written all this great configuration code. You might confidently hit run on your IDE and, well, nothing happens. You might be sitting there scratching your head wondering, where is my window? I built the foundation, I framed the walls. Why on earth can't I see my house? That is exactly the contrast between existing in memory and actually being drawn on the screen. Constructing a JFrame object, even after correctly setting its size and title, does not immediately display the window. It just silently builds it in the background memory. To actually reveal it to your user, you have to explicitly call a completely separate, specific command.
And that magic command is appFrame.setVisibleTrue. Calling this method is literally like pulling back the velvet curtain on a stage or flipping the main light breaker in our digital house. It tells Java, okay, we are completely done building and configuring. Go ahead and put it on the screen so people can finally see our empty window. Once the single line runs, boom, your beautiful canvas suddenly appears.
Let's move to and see how this builds into section 5, adding custom components, moving in the furniture.
So right now you have a perfectly constructed, highly visible, completely empty gray box. To make it a real functioning application, we need to put interesting things inside of it. And this is exactly where the J component comes into play. A J component is essentially a blank graphical component that you, the programmer, customize with your own code to draw whatever you want. If the J-frame is the structural house, the J component is the raw wood and fabric you use to build custom digital furniture for the empty rooms. You write code extending this basic component to create exactly what your specific application needs. So, what exactly can you add to your new J-frame? Well, the possibilities really open up here. You can add those custom J component objects we just talked about. You can use them to draw basic 2D shapes like colorful rectangles, circles, and intersecting lines to create completely custom graphics. Or you can add pre-built interactive elements like a text field where a user can actually type in their own information. These specific components are what make a GUI actually useful and, frankly, a lot of fun to use. And the best part? Adding these interactive elements is incredibly straightforward. Once you've created a component in your code, say a text field named output field, you simply use the add method, frame.addOutputField. This beautifully simple syntax takes your piece of digital furniture and securely places it directly into the application's main top-level container. It really is that easy to start populating your window with life. Which brings us to the absolute most exciting part of this explainer. We have poured the foundation, we framed the walls, turned on the lights, and learned how to bring the interactive furniture in. You now have a firm, robust grasp of the fundamental code needed to construct a graphical application in Java. So I want to empower you with this final thought. Now that you have your beautifully empty digital canvas, what will you draw first? Seriously, go open up your IDE, import that JFrame, and start building your masterpiece. Thanks for joining me on this explainer, and happy coding.